Mixed exercise chapter 5, polar coordinate. Let's start. Actually, there are a lot of questions here, so I will solve the questions with E and P together. So I'll start with number 2. Sketch the curve with equation A equals R equals A 1 plus cos theta. Theta is between 0 to pi, and A is larger than 0. And R equals 2A sec theta for negative pi over 2 and pi over 2, and same diagram. So half line, theta equals alpha 0 to pi over 2, A and B. Okay, so let's sketch the curve first. I cannot remember the graph very well, so usually I always do from the scratch. So when theta is 0, cos theta is 1, so 2a. When theta is pi over 2, cos theta is 0, so this is a. And when theta is pi, then cos pi is negative 1, which is 0. And there is no negative value here, so R is always positive. So it must be something like this. Something like this. And 2, R equals to 2a sec theta. And let me multiply cos theta on both sides. So R cos theta becomes 2a, and R cos theta is x equals 2a. So this is a vertical line. So when theta is negative pi over 2, it's infinite. And pi over 2 also infinite. So actually, the line is like this. So here, R equals 2a sec theta. And this one, R equals a 1 plus cos theta. And let's draw the half line here. And A and B, as I remember, OB is 2OA. So this is R, and this is 2R. So coordinate of A is R comma theta, because this is the same theta. And B is 2R comma theta. So A here. So R equals A 1 plus, but in this case, theta is alpha. So here, alpha, also alpha, cos alpha, and R equals 2R equals 2a sec alpha. So when we cancel 2 on both sides, then both are R's. So a 1 plus cos alpha becomes a sec alpha. So again, multiply cos alpha on both sides, then cos squared of alpha plus cos alpha minus 1 equals 0. So cos alpha becomes negative 1 plus minus square root of 5 over 2. But here, as alpha is acute angle between 0 to pi over 2, so cos alpha should be positive. Therefore, cos alpha is negative 1 plus root of 5 over 2. And number 3, sketch in the same diagram 3 cos alpha. R equals 3 cos theta. R equals 1 plus cos theta. And find the area, the region lying inside both curve. So again, 3 cos alpha theta. Actually, this R1 plus cos theta is same here, where A is 1. So let me make it 2, 1, 0. So this is pi, 0 to pi. And just continue, pi over 3 pi over 2 becomes 0 again. So 1, and 2 pi again 2. So I think I make it a little bit too heart shape like, but anyway, it may look like this. So this is r 1 plus cos theta, and 3 cos theta is, I think that is the circle, because this is r squared equals 3 cos theta times r. So r squared is x squared plus y squared equals 3x. So x minus 3 over 2 squared plus y squared becomes 9 over 4. So this one is 2 over 3 and 0, and here 2 over 3. And the radius also 2 over 3. So this is 2 over 3. So like this, circle like this. So this is the one. So here it says between two curve, between two curve means here. So now we need to understand what is the intersection. So 3 cos theta becomes 1 plus cos theta. Cos theta is 1 over 2, means theta could be pi over 3 and 5 pi over 3. So here pi over 3, and here 5 pi over 3. So here is the area between the curve and the polar axis. So this one is only, actually it is not between two curves. It is only just one curve. So here, integral 0 to pi over 3 and half r squared. So this is blue. Blue is 1 plus cos theta squared d theta. Plus, and here, this red part here, this is pi over 3, but I think I need to know when this becomes 0, because this is 0. So that is pi over 2. So here, between pi over 3 to pi over 2, half, the red one is 3 cos theta. So 3 cos theta squared over d theta. And actually, from the symmetricity, so this part and these parts are same. So we can multiply by 2. This is the what we need to find. Integral 0 to pi over 3, 1 plus 2 cos theta plus cos squared over theta, we already know it is 1 plus cos double theta over 2 d theta, plus 9 integral 2 1 plus cos 2 theta d theta, pi over 2, 3 pi over 2, like this. So actually, this and this is same. So we can say theta plus 2 sine theta. This is just simple. And 0 to pi over 3 plus, no, it's different. I mean, they are like, because this has 9, so anyway, we need to make it again. So pi over, so here 3 over 2 theta, and sine double theta over 4, 0 to pi over 3, plus 9 over 2 theta plus sine double theta over 2, pi over 3, pi over 2. So here, pi over 2 plus sine square root of 3 and 0 plus 1 over 4 square root of 3 over 2 plus, minus 0 plus 9 over 2 pi over 2 minus pi over 3 plus half sine pi is 0 minus sine pi over 3, 2 pi over 3 is square root of 3 over 2. So now here pi over 6 minus square root of 3 over 4 pi over 2 square root of 3 square root of 3 and over 8. So 9 square root of 3 over 8 plus 3 over 4 pi minus 9 over 8 square root of 3. Oh. Therefore, 5 pi over 4. Yeah. Check the answers, please. Yeah. And number 5. Shade the region R, the polar coordinate. Okay. So let's do that. R equals 4 cos double theta. So I will find the graph. So negative pi over 4 and because this is double theta, so just let me think of double theta. So double theta is between negative pi over 2 and pi over 2. So double theta becomes negative pi over 2, negative pi over 4, 0, pi over 4, pi over 2. Then R 0 and 0. And negative pi over 4 is square root of 2 over 2 times 4. 2 square root of 2. 0 is 4. So 2 square root of 2, like this. Here then theta is negative pi over 4, negative pi over 8, 0, negative pi over 8, pi over 4. Here plus. So negative pi over 4, 0. And negative pi over 8, 2 square root of 2. And 4. And pi over 8, 2 square root of 2. And pi over 4, again 0. So this one look like a little bit this strange shape. So after this, the area of R, so here is inside here. And area of R is the, so now we can make it from 0 to pi over 4. We will find the upper side and times 2. I mean, you can, of course, you can make it from pi over 4 to pi over 4. But always 0 makes the calculation easier. So pi over 2, half of 0 to pi over 4. And R is 4 cos 2 theta squared over d theta. This will be the answer. Number 9, sorry. The diagram shows, these two curves and find the polar coordinate of points of intersection. Okay, so number 9, A 1 plus cos theta is 3A cos theta. So 2 cos theta is 1, cos theta is 1 over 2. So polar coordinate. So when theta is pi over 3 and 5 pi over 3. So P is pi over pi over 3 comma. When it is pi over 3, 3A over 2. So like this. Find the area shaded in the figure. So again, this is like it is like this, OP. And again, this is two separate parts. This one is the part of the first curve, and this one is part of the second curve. So half of 0 to pi over 3 a squared 1 plus cos theta squared d theta plus pi over 3 half, this is 3, and 0, when it is 0, it is pi over 2. And that is 3a cos theta squared d theta. And you can calculate it. And number 10. Let's obtain the Cartesian equation. Okay. So here r squared is sec 2 theta. So r squared is 1 over cos 2 theta. So r squared is cos 2 theta. Let me think about it. Sec 2 theta. Cos 2 theta is r squared 1 minus 2 sine squared of theta becomes 1. R squared minus 2 r sine theta squared becomes 1. R squared is x squared plus y squared minus 2y squared becomes 1. So x squared minus y squared equals 1. This is the answer. And r squared is cosecant double theta. So here sine double theta becomes 1. And r squared 2 sine theta cos theta becomes 1. So 1 over 2. Here r sine theta, r cos theta. So xy becomes 1 over 2. Y is 1 over 2x. Number 11. Showing on an argon diagram, locus. So this is the distance between z n1, I. The distance is square root 2. So here 1, 1, and distance is square root 2. Oh, this is circle. I'm not very good. Yeah, something like this. But no shade. So this is on the diagram. To show that this locus of points can be represented like this. Okay, so z is x plus yi. So z x plus y is r cos theta plus I r sin theta. So when it comes here, r cos theta minus 1 plus r sin theta minus 1 I, magnitude is square root 2. So the r cos theta minus 1 squared plus r sin theta minus 1 squared becomes 2. Oh, yeah, that's right. So here r squared cos squared minus 2r cos theta plus 1 plus r squared sin squared of theta 2r sin theta minus 1 plus 1 equals 2. And we don't have 2 anymore. And r squared cos squared plus sin squared minus 2r cos theta minus 2r sine theta equals 0. Like this. So now this is Pythagorean identities 1, so r squared becomes blah blah blah. But we can make some assumption that r is not 0. Actually, it can be 0, but let's make it. So anyway, so here we cancel out 1r, becomes 2 cos theta plus 2 sine theta. This is r. And z is like that. So the argument of z is between there. Show by sketching on your argon diagram set of a point A. So here this is like inside of this, but only argument of z is pi over 6 to pi over 2. So maybe between here to here and inside. So this one, like this. So find correct to 3 significant figure the area of the region defined by blah blah blah. So we will find it. So integral half pi over 6 to pi over 2 r squared. So 2 cos theta plus sine theta squared of the theta. So we can calculate it to integral pi over 6 pi over 2 sine squared over plus cosine squared, which is 1, plus 2 sine cosine, which is a sine 2 theta d theta, and 2 theta minus cos double theta over 2 pi over 2 pi over 6 2 pi over 2 minus pi over 6, which is 1 over 3 pi minus half cos pi minus cos pi over 3, like this. So 3, so pi 2 pi over 3 minus plus 3 over 2. I think this is the answer. Please check. And number 12. Diagram shows this one. Okay. The point A is value of r equals to 2. And point A lies on C. And point B lies on initial. Okay. So the area, we can find it. So here from the graph, A and B, and we know this radius is 2, it says. So 2 becomes a full cos 2 theta. Cos double theta becomes 1 over 2. Double theta should be pi over 3. Theta is pi over 6. So here we calculate this area first. Integral half of what is that? 16 cos squared over 2 theta d theta from 0 to pi over 6. Then the shaded area minus this one. We know this is 2 and this is pi over 6. So actually it's easy to find the area. This is 1, this is square root of 3. So the triangular area is square root of 3 over 2. So when you calculate this one, then you will find the area. Number 13. Here, area of the shaded region in this one. So, or the line tangent, okay. So let's find the tangent line. So r equals 4 sine 2 theta. X becomes r cos theta. So 4 sine 2 theta times cos theta. Y becomes r sine theta, 4 sine 2 theta times sine theta. We need to find the dy over dx, then dy over d theta over dx over d theta. So y, the product rule. So 4 cos 2 theta sine theta plus sine 2 theta cos theta. And here for another doubling the product rule, then 2 cos 2 theta cos theta minus sine 2 theta cos sine theta. So this is the derivative of that. And here we need to find when we have the vertical tangent, which is the denominator should be 0. So 4 cos 2 theta cos theta minus sine y4 is 2. And sine 2 theta sine theta should be 0. So here cos 2 theta cos theta minus 2 sine square root of theta cos theta becomes 0. So here 2 cos theta, and this is cos 2 theta. So let me make it 2 sine square root of theta minus sine square root of theta becomes 0. So sine square root of theta is 1 over 3. Therefore, sine theta is 1 over square root of 3. Because of the graph, we can tell this is like on the first quadrant, which could be acute angle. Sine theta should be positive. So this is the one. We don't know what is the angle yet, but anyway, we know this is the one. And so this one, when we see the diagram here, we see this triangle and this part. So this part is the, what is that? Is the, from the integration of this graph. So integral, let's see, we don't know this theta yet, just we call it alpha. So let's call this alpha. So integral 0 to alpha half of 16 sine square root of 2 theta d theta. We subtracted this from here. So now we have this, we know, actually you can use the calculator. Yeah, but anyway, just let me continue a little bit. So cos theta is 1 over square root of 3, and we understand sine theta is 1 over square root of 3. Cos theta is square root of 2 over square root of 3. And for sine square root of theta, we can tell this size. So 4, 2, multiply of the sine theta and cos theta, square root of 2 over 3. So 8 square root of 2 over 3. And we know sine theta is square root of 3, 1 over square root of 3. So this height is 8 square root of 2 over 3 times 1 over square root of 3. So here 3 square root of 3, 8 square root of 2. And here 16 over 3 square root of 3. So the triangle area, now we can tell. It's 27. So 27, 8 times 16 square root of 2 over 2. Because now we are finding this area. So here 64 square root of 2 over 27 minus 1 over 2, blah, blah, blah. But when you calculate this one, I think you can use sine theta and cos theta. Or, yeah, as I mentioned, actually, because you can use the calculator, you can find the alpha, which is acute angle here, then you can plug in there.